Right, there we go. Hey there, everybody. It is 2:01 UTC on the 17th of July, 2018. And howdy, howdy. What's up, everybody? Another live stream with Astronomy Daily Live. So cheers. Bobby is back on the panel. Hey, Bobby, what's happening?
Nothing much, Cosmic. What about you?
Everything's really good here. As I said, it was sort of a fast day. It feels as though I don't know, I didn't exactly lose it, but man, it was pretty slippery today. So just kind of like
Yeah,
pretty quick.
we need some water.
Mm, yes, and yeah, I'm actually I should probably warn everybody ahead of time that probably in the next 20 minutes or so, I'm going to take a quick, like 2 or 3 minute pause, um, just so I can take care of a little extra business here. So yeah, that won't be for a while at least. So yeah, come on in, everybody, into the ever-growing circle of friends, um, where we, you know, turn off the TV, forget about the news, and think and talk astronomical things and science, and sometimes some tangents, but yeah, not hopefully not too many of those. But hey, you know, this is I guess in the Twitch world, this is sort of what's called in real life, IRL. So yeah, this is uh, except for me talking this much, this is pretty much how it is here. Um, just sort of, thinking astronomical things, and instead of keeping those astronomical thoughts in my head, I'm, spreading it around a little bit. So hope you enjoy. Andy, good morning. Good morning. Hope you're well. Everything's good here. Yeah, the sun is just beginning to set now. So it's probably got another, oh, I don't know. It's got at least another 20 minutes or so, something like that. So it's sunsetty here. Cloudy though. We're ramping up the monsoons. So that keeps uh that keeps the clouds in, which for an astronomer, that sort of sucks. That's why one of the things that I would really like to get into is radio astronomy, because with radio astronomy, the atmosphere is transparent. It's it's uh, um, it's as if it's not there at all, and that uh, you know I don't think I don't think that it's wise to like do radio observations like while it's raining, but it can be cloudy. It can be the middle of the day. It can be the middle of the night. It doesn't matter. It's just whenever your object is up, you can look at it and cool. So yeah, I want to build some kind of a radio interferometer here. I've I'm on 10 acres, and I've got well, I mean it's basically a box, right? A square, I guess, and and so I think from corner to corner, diagonally, I think that's something like 400 and some feet. So theoretically, I could build a regular telescope with that distance between two or more receivers, and I'd have some pretty good high spatial resolution that way. So yeah, Who knows? Someday. I've got to get better with radio before I do any of that, though. Oh, yeah, Bobby, can you mute yourself, please? And I'm going to turn you down too. I forgot about that. Thanks, thanks, our instro for the reminder. Okay, cool. All right, so Bobby's turned down to a reasonable thing, and I see that he has muted himself. So mute, you must be mute. Unless, of course, you want to chime in, Bobby, which is any time. Just remember to unmute yourself.
Yeah. So what I'm doing, I was having I was Chromecasting the Hangout session and stuff. I was wondering if that was it, and I'll cast and use this little receiver right here.
Okay. All right. I am going to, we yesterday we talked a little bit about trans-Neptunian objects, and I was actually looking at the Wikipedia page on that today, and it's actually I think it does a pretty good job at sort of laying it out. I wanted to show a couple of the graphics off, which I thought were extremely informative. Maybe a little busy, but pretty informative. So I'm going to share my screen and hide that and go over here.
How many people showed up for your rabbit stream yesterday?
There were two others and myself.
Okay.
So yeah, that's another thing that I think just sort of has to catch on. And I think if I, stick to a schedule and advertise it in the best way I can, without being annoying or anything. So trans-Neptunian object. I just wanted to cover this a little bit more, just because we really didn't get into what these things are. I just sort of showed you a list, and it's like, but there's a lot to find out about these things. So as the name implies, right? These are all objects that are further away from the sun than Neptune. And Neptune, it says here at least that Neptune's about 30 AU from the sun. And an AU, of course, is a astronomical unit, which is the average distance between the Earth and the sun. So Neptune is 30 times further out from the sun than we are. So that's pretty far. But Neptune is pretty amazing. And what has been recently discovered is sort of this new section of the solar system that nobody really knew was even there. So the first of these trans-Neptunian objects to be discovered was, of course, in 1930 when Clyde Tombaugh discovered Pluto, and it was found to be, trans-Neptunian. But it actually wasn't until I think like 1992. Does it say here? It probably does. I'm probably just repeating what I just read. Yeah, so in 1992, they discovered second TNO, which is this guy. I think it's got a different name now. Albion. Yeah, Albion. Now, I guess technically, Albion would have been the third one because I think they discovered Charon, Pluto's moon, if you want to call it that. I think like in 1978. So Albion would be number three, but but it was after Albion that they were sort of like, huh, I wonder if these, there's more uh, like these. And it turns out that there are. In fact, there's an object that's even apparently larger than Pluto, and that's Eris. Let's see. So let's go to this plot, which I thought was nice. Smartphone to make sure that that you're seeing, or that you're seeing what you should be seeing. Always like to check those kinds of things. Yeah. It's hard to keep track of muting and unmuting. So I'm counting on any of my panelists to take care of those kinds of things. So, hey there, Bill. Nice to see you in the chat. Greetings. We're looking at trans-Neptunian objects. And last night I talked about these a little bit, but I was looking at the Wikipedia page, and it's like, wow, this is pretty good. So I just wanted to go over a few of these things. So along the x-axis here, right, that's sort of like distance. And you can see actually the distance up here, right? Saturn is at about 10 AU, Uranus is at around 20 AU, Neptune is at around 30 AU, Pluto is around 40 AU. It's kind of interesting how they all sort of separate themselves like that. Isn't that interesting, huh? And so this is sort of a chart showing various things. And you know what? Okay, this is period. Okay, so period in years, right? So Pluto, here's Pluto, and there's its sort of relative size, right? I guess this is 1,000 kilometers across. So yeah, Pluto I think is like 2,400 kilometers across. So that's about right. So here's Pluto, has an orbital period of about 250 years or so, and as I said, is about 40 astronomical units out. And so that's sort of how you read all these other ones, right? Makemake is this one. Looks like it's a little bit more than 1,000 kilometers across, and it's at around 45 AU. Has an orbital period of about 300 years. Now, these are some kind of ratios. Neptune. Okay, so Neptune, of course, is 1:1. Here's a 4:5 resonance with Neptune. Here's a 3:4. Here's a 2:3. I don't know if I'm reading this right or not. Here's a 1:2. 1:2 resonance. I guess. with the orbital period. So orbital period here is about 165. So 165 times 2 is whatever it is, 330. 330. Yeah, so this is some kind of orbital resonance with Neptune. Here's 1 to 4, here's 1 to 3, 1 to 2, 1 to 1. Bode's law. Yeah. 4 to 5, 3 to 4, 4 to 7, 3 to 7. Interesting. And you can sort of see that, these objects aren't necessarily evenly distributed, right? There's a whole bunch of objects that they're calling plutinos, uh, and they all are about the same distance away from the sun as Pluto is, and so yeah, they bunch up like that. So you really haven't found any um, uh, at these distances. Now, I'm just noticing now that along this axis also they have inclination. So this is the inclination to the ecliptic, which is the sort of the imaginary flat plane that goes through the sun's equator and extends itself out in sort of a flat plane, a flat disk. So that would be at 0
Yes.
degrees, and so this is the inclination. See, so Pluto is inclined, I think around 18 or 19 degrees, right? Which yeah, it's close, at least. Eris, which is absolutely huge, right? Extremely far away, right? 60, 67, 68 AU out. Huge, right? Absolutely huge. Highly inclined, right? That's like 45 degrees. So that's pretty amazing. That's pretty amazing.
Can we
And
see those on the telescope? And I'm sorry about the ruckus that's out there. I had to keep it muted for quite some time.
the ruckus. Where's that ruckus? Um, you know, trans Neptunian objects are uh, the ones that have been found are really big, right? I mean, we looked at that list last night, and there were a couple that were 100 kilometers in size. So most you discovered so far are really big. So yes, they're very big, but they're really far away. So their apparent brightness, what um, how bright they seem to be, um, is extremely faint. I mean, like really faint. Um, 22nd, 23rd, 25th magnitude. So like really faint. Um, even the largest telescopes in the world have problems with that. So HSTs makes it a little bit easier, but again, they would have to take some pretty long exposures in order to get that, because that's all all these for the most part are really faint. I mean, Pluto is pretty bright, comparatively speaking. I think right now it's like magnitude 14.6. So in order to see Pluto right now, um, you would definitely need probably at least a 16, 18, 20-inch telescope or so in order to see it. sometimes it gets a little bit brighter than that. I think it gets up to about 13 and a half. So, but even that, you're not going to see that in anything smaller than like a 12-inch or a 14-inch telescope.
Is it possible that the HST does still have this data right now?
It's I th- I can say with pretty good certainty that the HST has probably looked at a few of these. Yep, we can let's go for it. Let's see if HST has seen Iris. Let's see if HST has seen Iris. So I'm going to turn off the name resolver because otherwise it may not understand what I'm asking it. Turn all these on. Let's see if it can get it from just that. Haha. So they looked at it in 2015 at least, and then 2007. So two different epochs looked at Iris. Yeah, and of course HST is going to be looking at. Oh, okay. So it's doing an occultation on the 4th of August. Cool, cool. I I I was actually going to mention here too that Pluto is going to be occulting a 13th magnitude star on the 15th of August. Uh, it, it's
You
around 5:30 UTC. Um, so yeah, very cool. Let's just see. Now, I mean, this is just going to look like, at least my guess is that we're not going to actually see any surface or anything. It's just going to look like a star. But let's look and see what it is.
you were right about exposure time when it comes to those objects.
Yeah, some of them, are long. Huh, I'm not seeing anything in here too extraordinary. Um, I mean, there's a galaxy here and all of that, but there's some galaxies back here. But maybe that's it. Probably not. You know, as I said, this guy is going to be really, really small or faint. So, yeah, wow, it could be, it could be anything. So yeah, I don't know if we're going to be able to pick that out or not. Probably not. Sometimes associated with these things, there are papers, discovery of the Makemakayan moon. Yeah, but these guys are looking at Eris. Hmm. Let's see. They're pointing around. See, they're moving. They're moving around. 20 arc seconds. Back to 5. Back to 5. 5. 5. 5. 5. 5. 20. So they're scanning around a little bit. So let's see. Let's just go to the next one. I don't think that we're going to see anything because I don't know what to look for, right? It's definitely not going to be these bright ones. At least I don't think so. But yeah, hard to know. I would think it'd be more like one of these fainter things. Don't know.
I seen they got some for about maybe 2 minutes, 2 to 5 minutes and stuff. Can you look at those?
Where?
Like
This is
like if you like go like around
720.
January 2015, they got some shorter, like 1 minute, 2 minute, 5 minutes.
Okay, these ones, like these 80-second ones.
Yeah.
That's just going to make everything even fainter though, because the longer or shorter exposure. Yeah, it's probably in there somewhere. Let's see. We can read the proposal. Recent HST observations, searching deeper than ever before, have discovered a very distinct family of small, faint, circumbinary satellites around Pluto and Charon. Pluto has looked like the oddball of the solar system many times in the past, with its inclined and eccentric trans-Neptunian orbit, its enormous satellite Charon, and its volatile ice-rich surface composition. But in each of these matters, subsequent discoveries revealed that Pluto was not unique, merely the first of an entirely new class of objects. This proposal aims to determine if Pluto's family of small faint satellites. Yeah, okay. Well, okay, yeah. Deep imaging of Eris and Makemake. So Eris is in there, right? But we don't know where.
So it's possible to press your bug on Maki Maki or no luck at all.
It's going to be the same kind of a thing where it's just gonna look like a faint star, right? Makemake. What was it? 13668? Yeah. So yeah, I mean, this is gonna look pretty much exactly the same, right? Just a bunch of there's a cool looking weird looking thing there. That's kind of interesting. Huh. Looks like, I don't know. I mean, it looks like some kind of galaxy something, maybe? Planetary nebula? I don't know. That's kind of weird looking. But apparently Makemake is in this image too. Who knows where? Don't know.
Our Astro got a good point. It says Eris is about 40 kilometers smaller in diameter, massing 25% more than Pluto.
Okay, yeah, yeah. You know, it's I don't know if they have really good numbers on the diameter of Eris yet. Of course, we've got a really, really, really good diameter of Pluto now, but yeah, I think in terms of mass and size, we're going by reflected light, and you have to make a few assumptions there. So those assumptions are going to dictate uh, what you think the size and mass of that object is. So yeah, I mean, uh, I think we can agree though that Eris is big. It may not be the biggest, but it definitely isn't the smallest. It's a pretty big boy. So
Is
yeah,
there
there's a bunch of
a
guess.
possibility that the New Horizon probe can look at those?
I I you know the New Horizon probe is has the potential um, of being around for the next 50 years, right? I mean, it's nuclear, and I think there's enough fuel. I think Alan Stern himself said that that he thought that there was enough fuel for 50 years of service. So where can you go in 50 years? Um, I don't know. I don't know. I mean, it sort of depends on where these objects are, right? Uh, it just so happened, right, that this flyby that they're going to be doing at the end of the year, um, that that was almost luck, right? It's like after Pluto, it's like, okay, we have this spacecraft. What do we do with it, right? There's all kinds of things that can be done. Well, let's see if, with as little effort as possible, can we change our trajectory and intercept another object? And the answer in this case was yes. So can they do that again? They probably can. Um, uh, you know, they they now have a choice of over 2,300 objects. Now, not all of them are going to be in the right place at the right time, but I would think that a few of those, a few of those might be, right? And if you look at the chart again here, right, New Horizons is just past Pluto, right? So I mean, it's this far out. Look at all this stuff out here. There's a lot. There's a lot of stuff, and this is just the known stuff. I wouldn't be surprised. I wouldn't be surprised if there were um, probably tens of millions of these objects out there. Maybe even this size, 100 kilometers or bigger. I wouldn't be surprised uh, if there were quite a few out there, and we're just discovering them now because we rely on reflected light. We have to be able to see these objects um, and detect their motion. There are other ways of doing that, and that's a project that I'm thinking about pursuing. We'll see. We'll see. I still have to run a bunch of numbers and stuff. Anyway, so to answer your question, Bobby, the answer is yes. Whether they can specifically, go to Makemake or Iris, we don't know, right? I mean, uh, Makemake is obviously closer, right? So it would take less time. Iris, is almost twice as far from the sun as Pluto is. So, that's going to take a while to get there if you want to, even if you can, right?
Sorry, audience trolls. My receiver was causing a lot of feedback, and I moved it around and then stopped.
You're a dangerous man, Bobby. Beware the Bobby. He will destroy you. All right, so let's keep moving here because I think there were some other. Okay, that's just sort of a graphic. I thought there was another. This I thought was kind of interesting. Okay, so here are all the objects that make up the solar system. Right, here's all of them in this big, huge box here. Right, so we've got planets in the blue box. We've got dwarf planets in the green box. We've got a solar system bodies, small ones. So asteroids, and then we've got satellites, moons, right over here. So then within those big categories, 1, 2, 3, 4 categories, we break that up into smaller ones where you have the minor planets, which a lot of them are dwarf planets, and some of them are small solar system bodies, right? And So that's that. You've got the trans-Neptunian objects, which could be dwarf planets, solar system bodies. How do I read that? Comets? Comets? I guess. And also moons.
What are centaurs?
Centaurs are a class of asteroids, and I guess maybe a few moons too. Man, I always forget. I think it's a class of asteroids that are generally between Saturn and Neptune, if I remember right. But let's go find out. I got to say, if I was a kid today, I would be like completely absorbed into the internet, right? Google is like absolutely amazing. Back when I was a kid, what I had was the Reader's Guide to Periodical Literature. That was my Google. Small bodies orbiting the sun between Jupiter and Neptune. So yeah, it's sort of a region of the solar system where those kinds of objects are. So it's been estimated, it says, that there are around 44,000 of them, larger than a kilometer. Pretty amazing. So, and then I guess within the dwarf planets and within the minor planets are, these centaurs, and then there are these centaurs. So these are just the big ones, and these are just the small ones. And I guess some centaurs can be comets as well. Am I reading that right? I think so. And then you've got the Plutoids here, which are trans-Neptunian, minor planets and/or dwarf planets. So those are all the objects that we know about right now. And of course, there's a star in there too. And there's rings. I don't know where to put rings here. Yeah, Uncle Bill, I noticed that, and as I said, I think that's the only way that I can explain that, is that there are big centaurs and there are small centaurs. I don't know if this can help us understand that at all. Let's find out. So there's the distribution of the centaurs. So, maybe this is all. I see. Okay. So they're showing the Trojans, which are in this gray area here. Let's blow this up a little bit. So this is not a very good graphic, but oh well. So these are the Trojans, the gray dudes. The centaurs are going to be these green ones here, and then these are the trans-Neptunians, which, yeah, I don't like that picture. That I don't like it because I don't necessarily think that it's properly depicting. Yeah, they're not showing 44,000 centaurs here, right? So, that's a little strange and annoying. Let's see. So, I think that was about it. We can look at this really quick. Just this is largest known trans-Neptunian objects. So this is showing Eris as slightly smaller than Pluto. Whether it is or not, who knows? Apparently, it has a moon. It's kind of interesting that a lot of these objects, do have quite a few companions. Sedna, Makemake. This one they think is like an ellipsoid in shape. They can determine those shapes by looking at the light curves and watching them rotate. And if they change in brightness in sort of a periodic way, then there either has to be something really, really interesting about the surface that makes it light and dark, or uh, it's changing shape, and actually what we're seeing, right, is just a two-dimensional uh, projection. So, if this is the shape, you can sort of imagine this rotating by 90 degrees. It would actually look smaller, which would make it appear fainter. And, that would happen in sort of a regular way that hopefully um, they're properly modeling. What, now whether it looks exactly like this shape, that's unlikely, right? But they can look at the light curves of these other guys and notice that the brightness doesn't really change all that much, which means that their surfaces don't have a substantial amount of light and dark and light and dark, and their shapes are basically spheres. Oh, so here's the Earth and the Moon down here too. So pretty interesting objects. They're as I said, this is sort of a new area that we really didn't even know was was there. Um, just sort of stumbled on them, and it's like, wow, pretty amazing. So yeah, now I think it's just a matter of discovering them, trying to characterize them if possible. The problem is that they're so far away that they're just really faint, right? They're really, really hard to get any light um, out of them at all. And you know, not only are they really far away, but most of them are like really, really dark anyway, right? So they might reflect. I mean, if they reflect 10% of their light, um, that would be really, really great, right? So, I mean, these things are really dark objects too, and they're far away. So that just makes them really, really, really hard to um, to figure out. Um, okay, cool. Yeah. So um, our instro is saying that they've been able to watch dysnomia orbit um, Eris, and using basic Keplerian math, was able to figure out the um, actually the mass I guess, of them both. You can do them both that way. So yeah, kind of interesting. Considerably more massive than Pluto, but possibly so. That sort of implies higher density, uh, and that can imply maybe what it's made of. Don't know. There's a lot of guesswork. A lot of guesswork based on a little bit of information, right? I mean, it's an educated guess, but it's still a guess. So yeah, trans-Neptunian objects are absolutely incredibly interesting. Just from a scientific standpoint, trying to get a handle on what is going on, right? So, well, let's see, where should we go from here? Yeah, and Uncle Bill, you're you may be right about that. I might be maybe exaggerating a little bit, but um, uh, so far, I'm here. Let me do this. Stop sharing. Go back over here. So, you know, I'm trying to think, but I'm thinking that so far, we have not found any icy comets or asteroids. We've seen at least a couple few icy moons, but as far as I know, all the asteroids and all the comets that we've ever, actually gone to and looked at, have looked like just big rocks, right? Big mountains. Um, I think that's true. So based on that, my guess is that most asteroids at least are going to be pretty low albedo, right? Pretty low reflectance. Um, okay, cool. Yeah, occultations are amazing tools. Um, uh, and that's why I'm pretty interested in using them possibly for discovery. So um, yeah, that's just an interesting possibility. Um, it doesn't work too well for small nearby asteroids, but I think it's going to work really well for relatively large asteroids that are very far away. So as I said, I still have to run all the numbers on that, but yeah, I'm I'm thinking that's a possibility. So lots of discovery. If we think that there are millions of them out there, and we only know of about 2,300 of them, then it's like you know uh, we can put our name on every single one of them. Let's do an object of the day, and I think that we should definitely uh, do an NGC uh, search here. NGC stands for New General Catalog, and it was developed. I want to say that the New General Catalog was put together. I don't know, in the 60s, the 70s. I'm not exactly sure. Maybe it goes back even further. I'm gonna have to investigate that a little bit. Um, but as of now, there are 7,840 NGC objects. And most of these are galaxies, globular clusters, um, um, open clusters, planetary nebulae, and gaseous nebulae. Now, Uncle Bill just posted something in chat that I'm going to look at. Diverse albedos of small trans-Neptunian objects. All right, Uncle Bill. Let's see. I have absolutely no problem, and in fact, I thoroughly enjoy uh, uh, being wrong about things, because I mean, as a scientist, oh come on, as a scientist, I um, you learn so much. Come on. So I'm going to search for this paper title, and in front of your eyes, you will see how terribly right or terribly wrong yours truly is about albedos of small trans-Neptunian objects. I can probably get away with that. Find it. Cha-ching. We will do an object of the day, but Uncle Bill always takes precedent. Let's see what they say here. So, discovery of trans-Neptunian object satellites and determining their orbit has recently enabled estimation of the size and albedo of several small TNOs. Compute the albedo and size limits for 20 TNOs. All right, let's get to the numbers, okay? Let's just assume that these guys know what they're doing, which is a good assumption, good assumption. But I want to see what these albedos are. Now, albedo is just a really fancy name for the percent of reflectance. So I think asphalt. Does asphalt have an albedo of something like 10%, 15%? I'm not exactly sure. It's pretty dark.
So this paper is like 12 years old exactly?
Oh, is it?
Uncle Bill says it's 12 years old.
12 years old? Okay.
12.
I want to see some numbers here. Here we go. Here we go. Okay, so 3.5%, 1.8, 3.3, 5.8. Here's a 14. Here's a 22. That's pretty high reflectance. Ooh, there's a 39. Holy moly. Okay. Am I reading the right column? Yeah. There's a 39, Uncle Bill. Pretty good. Okay. Now look at Pluto. Wow, now that shocks me a little bit. I didn't realize how reflective Pluto was. I mean, you look at the pictures and it's like, well, yeah, that makes sense. But I didn't realize it was that high. But as you can see, if you look at these 20, right, I'm seeing maybe an average of about 10% or so.
So what is an albedo?
That's, as I said, that's just a fancy word for percent reflectance. So sometimes you'll see it as a percent. Sometimes you'll see it as like 0.035, right? Here it's in terms of percent, so 3.5%. So that's just how much um, um, this object reflects its light, right? So I mean, it receives 100% of the light. It's reflecting back out into space, at least at the wavelengths being observed. Only 3.5% of that light is being reflected. So that's really, really dark, right? 1.8 is really, really dark. 22 is starting to get bright. We can actually, let's see if our friend again. I want to get the albedo of asphalt. Come on. I think it's somewhere around like 15%, but I don't know. Yeah, I'm seeing that plot there, and I think it's around 20%. There we go. So yeah, so on average, it's about 20% or so, and it looks like um, as as asphalt ages, it actually gets brighter and brighter and brighter, right? It reflects more. That's kind of cool. It's really, really dark at the beginning, but then it brightens up really fast. Huh, that's kind of cool.
I wonder
So,
what the albedo is for concrete.
well, I think that's showing that there too. I think that's yeah, those are the dotted lines here.
Uh,
So, um,
yeah, because we got concrete roads and sometimes we got little asphalt highways. We got concrete streets and asphalt highways
I
out
see.
our area.
Right, right. Well, I use this just as a reference, right? So now, I mean, everybody sort of knows what, how dark asphalt is. Uh, and if we know that it has an albedo of about 20 percent or so, then we can look at these albedos and say, okay, this object is about as dark as asphalt, right? But this one is much darker, and this one is darker still, and this one's brighter, right? I mean, it's reflecting more. So pretty cool. Pretty cool. Okay. Well, I'm glad to know that my my guess was at least in the ballpark. At least in the ballpark there, Uncle Bill. Angle of incidence to a certain degree. I don't. Um, Albedo, is a little bit more complicated than just reflectance. That's absolutely true. Um, I think yeah, it's like some particular angle, and yeah, I'm not exactly sure. I'd have to look that up. Let's look for an NGC object. So there's 7,840 NGC objects. I'm going to use our good old random.org here to choose our object of the day. Uh, yeah, yeah. As I said, Ata, I'm not necessarily here um, to do any kind of education or science communication or anything. But these topics, when you talk about astronomy, these terms are going to pop up, and I I guess I would much rather use them use these terms in a conversation than you know sort of stand up here and give you definitions. I want to actually show you some actual data, right? I mean, I think that is best. All right, here we go. Ready? Drum roll, please. 6838. All right. Let's uh uh let's go over to our favorite astronomical database. Now, Simbad has been around since the internet began, right? I started using Simbad in 1990. So it has been around for a really long time. And, it's evolved to a certain extent, but Simbad has information on everything. It doesn't have to be a galaxy or a cluster. It can be just a regular old star, right? If there's some kind of information about that object, it'll be in here. They they actually take they they've written software to ingest papers and parse them and find all this information that they can then put into their database. So it's absolutely amazing. So what was it? 6838. Okay.
Yeah, 6838, Gordon Uncle Bill.
BC 6838. 6838. Here we go. Oh, it is? It's M71? Ah. Well, it's sort of a double object of the day then. We're going to hit
A double whammy.
a double whammy. And yeah, this is actually there are two globular clusters in the sky. No, sorry. There are two clusters of stars in the sky that I absolutely love, and I can't believe that I missed this one. One of them is M37. Okay, Atta, when you can see M37, okay, look at M37 through your scope. It's absolutely fabulous. It's an open cluster in the constellation Auriga. It's Auriga. Auriga, the goat. I think it's a goat. It's just north of Orion. So I think you're not going to be able to see it right now. I think it's too close to the sun. But the other one that I absolutely love is M71, which I don't know why I didn't pick up on that. But yeah, I guess they probably do call it a globular cluster, but it's a very, very sort of loose glob. But it's absolutely fabulous. And yeah, it's in the constellation of Sagitta, which is just Sagitta is an arrow. And I guess how the story goes is that Sagittarius shoots the arrow Sagitta at Aquila the eagle, and he's missed, and so Sagitta has actually flown by, already gone by the eagle, and it's just flying off into space. This is a very, very easy object to find too, manually find. And yeah, this is this is a really, really good time of year to see this object in the early evening. I'll bet you that Uncle Bill will have things up in the Discord shortly. Should we go over there and find out? Let's see how much of a ninja he is. And then we'll go through this a little bit, and then we'll finish up. This is definitely one of my favorite object to see. The actually most of the photographs, as far as I'm concerned, don't do it justice. M71 is definitely one of those objects that you got to put your eyes on because it's fabulous. Let's see. Coming up a little slow. Here we go. So yeah, I think this is up now, right? Is that what you mean, Uncle Bill? Yeah, yeah. So I mean, it's coming up now. It's kind of hard to see here. So this way's north, this way's south. So this is east. This is west. Here, of course, is the Milky Way, right? And here's the summer triangle, right? Vega, Deneb, and Altair. There's the summer triangle. Here's Delphinus, the dolphin, down here. And as you can see, Sagitta, which you really can't see actually the constellation here. It's being obscured by the Telrad. But it's just a little constellation, little tiny little thing. And I think if Uncle Bill posts some zoom in ones, yeah, there we go. Thanks, Uncle Bill. You are the man. So there's Sagitta, right? And I guess it looks like an arrow, right? Sort of looks like an arrow, but see how easy it is to find, right? You go right in between these two stars and a little bit south, and bang, you're there. Easy to find. It's bright and fabulous through a telescope. Absolutely fabulous. All right, so Uncle Bill is posting other things. I can hear the oh, Discord is slow. Discord is slow. So there's the whole constellation of Sagitta. And as you can see, M71 is right there. Super, super easy to find. Now, one of the other interesting objects in the same area is over here. M27, the Dumbbell Nebula. This is also really, really easy to find. Really easy to find. Kind of hard to see here, but I'm going to point it out anyway, okay? If you take the end or the point of Sagitta, right? Take the point and go at a 90-degree angle, right? What you'll see relatively nearby are these 5 stars. 1, 2, 3, 4, 5. Sort of forms a what is that? A trapezoid, right? Like a trapezoid. Okay. And if you take these three bottom stars, go to the middle star, and just off of the middle star is M27, the dumbbell. And the dumbbell is also a great one to see through your scope, Otto. You'll be blown away when you see that. That's a planetary nebula. So as the story goes, it's one of the end states of a star. Probably what our solar system is going to look like is a lot like that. So yeah, not much of a challenge there either. Pretty easy to find. Pretty easy to find. All right, well, cool. Let's go back and sort of see here. Yeah, it's got a V magnitude of 6.1. So theoretically, in a really, really, really dark sky, you might be able to see that. Pretty small, right? 3.3 arc minutes in diameter. So yeah, pretty small. Pretty small. Looks like it's moving towards us. 16.9 kilometers per second. Let's see. It's got a few other names, including M71. Well studied. Very well studied. Yeah, your next trip is going to be really busy. Let's see, we've got a distance here. Let's see. I guess technically they're calling this a globular. So it's going to be, tens of thousands of light years away. Let's see. 0.004 megaparsecs. So a megaparsec is 3.26 million light years. I'm going to multiply that by 0.004. So yeah, 13,000 light years away. So yeah, that's pretty far. The center of our galaxy, I think, is I think they say it's about 30,000 light years away. So you can sort of we go back to oh yeah, there's the dumbbell there too. Thanks, Uncle Bill. Let's go back to this one. Now, what was I going to say about this? Shoot. What was I going to say about this? Oh, right. So the center of the galaxy is down over here, right, somewhere, and that's about 30,000 light years away. You can see that M71, NGC 6838, is pretty well lined up with the galactic equator. In fact, we can look at that. We can probably have the galactic coordinates here. Galactic coordinates? Yeah. So just 4 degrees south of the galactic equator. But it's on our side of the galaxy, right? Because it's only 13,000 light years away. But it's sort of, off to the left of the center. It's left of center. All right, what else do we have here? That's about it for that. Bill posted some pretty good shots. Let's see if I think the Sloan Digital Sky Survey should have this. Yeah. But I don't think that's what we actually see when we go here. I'm not quite sure how to change catalogs here. Let's see. SDSS 9, is that it? That's it. I wonder if those strips are real or if it's just data that hasn't come in. It sort of looks like those are real deals. So it looks like it just missed. It just got this guy on the edge. Yeah, that sort of sucks. Spitzer, Iris. Yeah. All right. Well, we'll stick to the Digital Sky Survey then. That's cool. It's pretty anyway. So as you can see, these two stars, right? These two stars here, that one and that one, are just to give you a sense of scale here. If I can, I will. Let's look at this one. So you see this star and this star and this one, these three right there. That's that one, and that one, right? So you got to rotate a little bit. You got to, yeah. But there it is, of course. Pretty easy, to pick out that that's not a star. That's something else. So you sort of can get a sense of scale here, right? So this field of view looks like it's maybe this outer circle. So it's just that. Can we see these two in that image? I don't think so. Where would that be? That'd be like a 90-degree angle here. I see angles and triangles. There it is. Whoop. I had it. There it is. So there's that one, and there's that one at a 90-degree angle. So cool. NGC 6838. Let's see if we got anything else interesting here. M71 is definitely want to look through a telescope with, though. Yeah. I imagine that most of us would see it as a smudge. Yeah, M27 isn't like that. If you get into a dark site, M27 pops. It really, really does. Yeah, cool. That works, Uncle Bill. It works really, really well. Thank you. So quite a few papers, right? 949 of them. I'm not even going to try. I'm not even going to try. But let's look at the first few, at least. These are usually ordered by date. So the latest ones are the ones that you see here. See, it was 6838, right? How can I forget that? I don't know. Let's 6838. on the absolute age of the metal-rich globular M71. There's a bunch of other, so light element abundances. That's pretty cool. Abundance variation. Okay, so they've found an eclipsing binary inside of M71. That's pretty cool. Not too surprising. First results of a photometric and astrometric study of the globular cluster M71. That's from 2000. It's a little while ago. Definitely not going to go through all of these. Too many. 1992, deep CCD photometry and variable stars in the metal-rich globular cluster M71. Let's see. Let's go up and look at what was it? Let's look at this one. So well, let me go to the paper. Don't want to tantalize with an abstract if we can't actually read the paper. Well, let's see.
Wah, wah, wah.
Let's try this. One thing about research, right, that you have, if you want to do research, you really have to be pretty stubborn when it comes to wanting to try to find things. You can't just fail once. Oh man, yeah. After the second failure, it gets a little harder because it's like, I guess I'm not going to be able to find that one. That makes me not happy at all. Try this. Oh yeah, the ADS. Okay, maybe. Come on. Oh, there's a PDF. You see it? We get it? Ha! Ha ha! Yay! So yeah, you just have to stick to things sometimes. Let's see. So we present the first results of a photometric and astrometric investigation. So they're looking at the positions of the stars and also the brightnesses of the stars, probably at different wavelengths. Yeah, B and V, right? So B, that's a wavelength, I think around, I want to say like around 4,800 angstroms or so, and maybe 100 angstroms wide. And V is around 5,500 angstroms, and I think is also about 100 angstroms wide. So they found almost 4,500 stars down to magnitude 18.5. it's not bad, you know, for 2000. Um, don't know. They'll probably talk about um, what instrumentation they used. I guess they found some blue stragglers. Cool. Probably a lot of color plots. You know, they plot the B magnitude versus the V magnitude. You can also do color magnitude plots, which is like B minus V versus V. So we'll probably see those in here. But yeah, just, you know, just sort of your basic measurement thing. So I guess they use a telescope on the ground. Okay. Actually say here. So 6 CCD frames of M71 obtained in 1995. Okay, so they went back a little bit. Very cool though. So let's see. So there's some proper motion, which is just how they're moving in the sky. I'm not going to get into all of this. I was just sort of looking for maybe like a table going. Yeah. So see, here's a color magnitude diagram, and those kinds of things usually bring out interesting correlations, interesting shapes that can then be compared to models, and that's what this line is. This line is some kind of a model saying, okay, you know, given these kinds of parameters, this is what the color magnitude diagram would be, and so then you can sort of compare that to the actual data, and you know, see if there's a good match or not. Now, whether there is a good match here or not, I don't know. Hard to tell. I'm sure they probably think it's a good match. These are also called Hertzsprung Russell diagrams um, because, well, there's a relationship between color and temperature, say. Um, and so, yeah, you know, this can be interpreted also as an HR diagram. Just by looking at the brightnesses of these objects with different filters. It's pretty amazing what we can do. There's no pretty pictures though. Bummer. Just a bunch of boring old plots, which are interesting enough. Photometry of the uh, bright stars, metallicity. Yeah, so they're trying to figure out how old it is, and again, you know, it's just ancient, right? Old. Pretty cool. Pretty cool. M71, as I said, is a great object to see through a telescope, and yeah, you know, at least these guys identified almost 4,500 stars. My my guess is that there's probably at least twice as many as that, at least. And maybe in later years, what this was done in 2000, um, I'll bet you, for instance, that Gaia uh, has got at least that many, at least. Oh man, yeah. Well, we're running really late. We're just having way too much fun here, but all fun, all fun must end eventually. So yeah, trying to be mindful of the time. Greatly appreciate you all coming in. Bobby, nice to see you again.
Yes.
Um, I'll keep inviting you in as long as you say, well, as long as you don't say, I'll just keep inviting you in, and that invitation goes out to anybody. Um, Anybody can be a panelist. Just send me an email, cosmiclettuce@gmail.com, and um, when I start up the Hangout, I get a little link, and I will send you that link, and then you can pop in too. And yeah, uh, I think it's pretty cool. So, all
Now,
right, I'm gonna get out of here.
now I was wondering if like if you're gonna be like going back on the rabbit, you can show me that movie that you showed yesterday.
Oh, you know what? I'll probably I'll probably show that movie again sometime soon. As I said, that's a kind of movie that I can probably watch maybe a couple times a year or so. So I will definitely play it again. Um, Probably not too soon. Probably not too soon. But it's there, right? It's on YouTube. So feel free to take a look at it um, whenever you wish. I encourage you to wear headphones in order to sort of get the full audio effect. Philip Glass is awesome, and that sound in that movie is like seriously intense. So with headphones on, it's really great. All right, I'm gonna get out of here. Peace, cheers. I will see you in a little less than 22 and a half hours from now. All right, take care, everybody. Have a great one, and I will see you on the spin. Don't get dizzy. All right, see you later. Bye.